This video will cover the lesson 4-6, Key Features of a Graph for Secondary 1 Math. Well, there are two terms right here at the top, domain and range. And understanding what these are going to help us as we try to explain the key features of the graph. One key feature is our domain, and that's just all the possible x values. Okay, all the possible x values on the graph. And the range is all the possible y values on this graph. Instead of making a big long list of all these x values that could be in the domain, we're actually going to write it as an interval. So if we remember back to our interval notation, we write it with the variable, so the domain will be x, and then we use that element of symbol, right? Almost looks like an E. And then we have parentheses and go to another value in parentheses, or a bracket if we're including that value. The same thing will work for the range, but we'll use y instead of x. So y would be an element from one value to another value. Okay, now that we have this set up, for each graph, we're going to identify the domain and range using the interval notation and tell whether the function is increasing or decreasing. So our domain, if we look at our graph on number 1, notice that it's going on forever this way, right? It's going to continue going to the left. It's going to continue going to the right. So our domain, or x values, is an element from negative infinity to positive infinity. Now that's because it's tilted. It's like a diagonal, which will continue moving left and continue moving right as it goes up and down as well. Then our range is going to be y is an element. Now, our y's, notice its line is continually going up and down, so it's going to be from negative infinity to infinity. One other note about our interval notation is that we always go from least to greatest. So here's our domain and our range. Now lastly, is the function increasing or decreasing? Really, that's just saying, is this going to have a positive or a negative slope? And notice as we go from left to right, and we go across this graph, and I'll do this arrow in yellow, so we go from left to right, what's happening with our line? It's going down, so that's going to be decreasing. Okay, number 2, we're doing the exact same thing. We're going to find the domain, the range, and then decide if it's increasing or decreasing. So our domain, remember that's our x values. Notice it's going on forever this way, and as we come up, it's getting steeper and steeper, but it still continues to move to the right. So our domain will be x is an element from negative infinity, because it goes off to the left, to infinity, because it keeps going to the right. Now our range, y is an element. We've got to decide how low is this going to go. So it's going down and down and down and down and down, and then it levels out right here. So what value does that go down to? Well, that's right between the -2 and the -4, so that's -3. And then it's going to go up. Oh, that's going to keep going up. So that's going to go up to positive infinity. So our range, y is an element from -3 to infinity. Now, is this function increasing or decreasing? So if we follow it, notice from left to right, what's going on? This is going up. So we say this function is increasing. Number 3, again, we're going to find our domain. So this is all of our x values. So x is an element from what to what? And as we go to the left, look, it's going to go on forever. As we go to the right, it's going down, but it continues to move to the right. So this is going to go from negative infinity, this is a parenthesis, negative infinity to infinity. Now the range, we're looking at how far it goes down. Notice it keeps going down, and that arrow is pointing down. So y is an element from negative infinity to, As it comes up, notice how it gets closer and closer to here, to this value. And that value is 3. So our range is negative infinity to 3. So this function, as we move from left to right, it bends and goes down, so it will be a decreasing function. Number 4. So find our domain. So as we look at our line, notice it's going to the right as it goes up, it's going to the left as it goes down, and so our domain, our x values, are between negative infinity and infinity. So x is an element from negative infinity to positive infinity. Now to find the range, notice the arrow is pointing up, so it's going to go up forever and down forever. So our range is going to be the interval, so that y is an element from negative infinity to positive infinity. Because our line is going to continue to go up and down forever. Okay, is the function increasing or decreasing? Again, we take a look, we say, okay, from left to right. As we go from left to right across our graph, that line goes up. So this function is increasing. You may have noticed that number 1 through number 4 was a combination of linear functions and exponential functions that we were graphing and writing the domain and range of and identifying if it was increasing or decreasing. But exponential functions have a distinct characteristic about them. Okay, so exponential functions in this form, we talk about f of x equals a to the x power, where a is greater than 0 and a is not 1. It has an asymptote. And this is a key word, an asymptote. Well, that asymptote, okay, is a line that the graph gets closer and closer and closer and closer and closer to, but never crosses or touches. So we'll never reach that value. The function in graph A, here to the right, has a horizontal asymptote at y equals negative 4. This dashed line right here, this is the horizontal asymptote at y equals negative 4. It may appear, looking at this graph, that the line, this graph right here of the exponential, touches y equals negative 4, but it never does. And so we can say distinctly that the range only goes down to negative 4 for this exponential function. Now, to help us just reiterate this, think about walking to a doorway of a room. If you're walking half the distance there, stopping, then walking half the distance, then stopping, walking half the distance, you will actually never reach the doorway. You'll get really close, but there will be some distance between you and the doorway. And that's what it's talking about. This function, this exponential function, will never reach the asymptote. So we're going to identify the asymptote of two different graphs. So the directions are, what are the equations for the asymptotes in the examples 2 and 3 on the previous page? So you'll want to flip back to the previous page on the notes and look at number 2. So number 2, you'll notice, and I have it here, it comes down and then levels out going to the left, right here. And it actually never reaches this. So our asymptote is right here. I'm going to put those dashed lines on it, okay? So there's our asymptote. And the equation of this horizontal line, the asymptote, is y equals negative 3. And notice how this relates to the range. The range was negative 3 to infinity. And the restriction to our range at negative 3 is because of this asymptote. So the asymptote is y equals negative 3. Okay, number 6. Now looking at number 3, right, we want to find or write the equation of the asymptote. Notice on this one, our graph is going down, but it's also leveling out at the top. So if I put in these dashed marks, this is where it's leveling out. So the equation of this horizontal line is y equals 3. And again, looking at your range, you'll notice that the range goes from negative infinity to positive 3. Notice that is our asymptote equation, y equals 3. All right, the other thing that we want to talk about, a characteristic of a graph, is the rate of change. And this is the ratio that describes how much the rise changes with respect to the run. If an equation is linear, like some of the examples we've seen, it doesn't matter where you look to find the rate of change, since it is constant. If the function is not linear, then we can find the average rate of change within the interval. So it's going to give us some interval to find that rate of change, but it's not the whole thing. And every interval, when we talk about these intervals, it's going to be talking about the x interval. So like x is an element from 1 to 2. So we're talking about the x value of 1 to the x value of 2. What's the rate of change? So let's look at an example. Number 7. So we're going to be finding the average rate of change for the given interval. We got to make sure it's reduced improper fractions when we do it. So we'll look here, we got our x interval from 0 to 2. So our graph, this exponential equation or function, at 0 is here. The x value is 0. This point is 0, negative 2. Okay, so the x value is 0 there. Then we're going to go find where the x value is 2. So if we go over 2, there's our x value of 2. Now we have to go up 1 to get on the graph of this function. So we're going from, I want to put these in red now, this point here to this point here, and we're finding the slope. Remember, to find the slope, we're going to do our rise over run. So we're going to rise, going from left to right, we're going to go up 3, and we're going to go our run over 2. So our average rate of change is 3 over 2. Okay, number 8. So on the graph A, so find the graph A, we're going from where x is 0 to where x is 3. So 0 is on the y-axis, so I'm going to find the point on the y-axis, this point here, and then we're 3. So I go over to 3 and go up till I am on the graph of this function. So up here. Now, to find our average rate of change, we're going to start with the one on the left. I'm going to go up. And notice we're going from negative 3 to positive 4. So that's a positive change of 7. And then we're going to go right 3. So our average rate of change for the interval from 0 to 3 is 7 over 3. Now we're going to do this for one more example. This is example number 1. Okay. So if we flip back to the graph for example number 1, we're going to find the average rate of change from the interval negative 3, 1. So I go negative 3 on x and find the line. So that's this point here. This value is negative 3, 3. And then I'm going to 1. So 1 would be here. This is 1, negative 5. So notice the x values. I'm focusing on the x values, negative 3 to 1. All right. The y values is determined by the point and the graph. So to find it, we go down, and that's going to be 8. So negative 8. And we're going to go to the right, 1, 2, 3, 4. So our average rate of change we would write as negative 8 over 4, which simplifies to negative 2. For the next 3 problems, we're going to do each of the following. We're going to first state the x and y intercepts as an ordered pair. That's going to put them in the form of x comma y in parentheses. B, we're going to state whether the function is increasing or decreasing. C, state the domain and range using interval notation. Remember, our domain will be x is an element from some value to some value with a comma in between those in parentheses. And the range will be y is an element from some value to some value in parentheses again with a comma in between. And then D, we're going to state the average rate of change for the given interval and write it as a reduced improper fraction. And then the E, write the equation of the asymptote, if any. Now remember, if it's an exponential, we'll have an asymptote. If it's linear, there will not be an asymptote. Okay, so number 10. Here's the graph of our exponential function. Part A asks for the x-intercept. Well, if we look at our graph, notice it's going down, 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 until it reaches almost a 1, and then it kind of levels out at 1. So that means this function will never cross the x-axis. So we're going to write none. For the y-intercept, we're looking for the point where this graph crosses the y-axis, which is here. And our ordered pair for the y-intercept is 0, 17. So the x value of 0, the y value of 17. Part B asks if this is an increasing or decreasing function. And as we move from left to right across the graph, if we go to left to right, we'll notice that it's going down, so it is a decreasing function. Okay, so C, we're going to write the domain and the range. The domain is all of the possible x values on this graph. And since we can tell on the left that it's going to continue to widen, it's going to be everything to the left. So it's going to go from negative infinity to, and then on the right, it's pointing directly to the right, so it's going to go on forever that direction to positive infinity. So we say x is an element from negative infinity to positive infinity. Now, for the range, we're going to use the variable y, right? But we're looking vertically, so it's going to continue to go up. We'll notice that on the left that it's continuing to point up. The right end of the graph shows that it's getting closer and closer to 1, but it'll actually never reach 1. So our interval for the range, we say is y is an element from 1 to positive infinity. Okay, part D. We're looking for the slope from this interval, so where x is 1 to where x is 3. So if we go over to x is 1 right here, and go up to where it crosses the graph, so this is our point we're going to go from, to 3, that's right here, up to the graph. Now that we have these 2 points, we're going to find the average rate of change between these 2 points. So we're going to start with the point on the left, and we're going to go down from 9 to 3, which is a decrease of 6, so negative 6. And then we're going to go to the right, 2, that's from 1 to 3, that's a positive 2. So our average rate of change is negative 6 over 2, which can simplify to negative 3. Alright, part E asks, what's the equation of the asymptote? Remember how we talked about earlier with our range that it went down to 1. But it didn't quite get to 1 because this is our asymptote. So we're going to write our equation as y equals 1. It's a horizontal line that crosses the y-axis at 1. Number 11, we're going to repeat the exact same thing we did the last one. So the first thing we need to do is find the x and y intercepts. So the x-intercept is where our graph crosses the x-axis, which is this point here. So the x value is 2, the y value is 0. So 2, 0. The y-intercept is where our line crosses the y-axis. So that's this point here. And that value is 0 for x and 4 for y. So the point 0, 4. Part B is this increasing or decreasing. So again, we look at it going left to right. It's going down, so it is decreasing. Part C, the domain. Remember, the domain is all of the x values that will be included on this function. So since the left or up arrow is also kind of pointing to the left, and the bottom arrow or right arrow is going to the right, our domain is going to be the interval from negative infinity to positive infinity. Now, for the range. Remember, the range is our y values. So this is continually going up, it's continually going down, and so our range, or the y values, will be the interval negative infinity to positive infinity. And most linear functions or equations will have this domain and range. Okay, D. X is an element from 1 to 4. But here we're trying to find the average rate of change. Okay, so our average rate of change. So we're going to go 1. So here's 1 on the x-axis. And we're going to go up to where it intersects the line. So here's our first point. And then we're going to go over to 4. So here, going down to where that value of 4 intersects the line. So we're going to take these 2 points and we're going to find our average rate of change. So we're going to decrease. So we're decreasing from 2 down to negative 4, which is negative 6. And then we're going to go to the right, 3. So positive 3. So our average rate of change is negative 6 over 3, which simplifies to negative 2. Part E asks if there is an asymptote we need to write the equation. Well, there is no asymptote because this is a linear equation or function. So we're going to simply write none. Number 12. So again, the same things. A, we need to find the x-intercept and y-intercept. So the x-intercept is where the line crosses the x-axis, which is at this point here. And the x value of that point is 1. The y value of this point is 0. Now for the y-intercept, we're going to have it where it crosses the y-axis, which this x value is 0. The y value is negative 3. We can look over here to the left of that point to see the negative 3. Part B asks if this is an increasing or decreasing function. And since we're going from left to right, again, we're going to be increasing. It's going up. So we write increasing. Okay, part C. Find the domain and range. So our domain, again, is the x values. And so looking at these, we are continually going to the right. Even if it's slightly, we're still moving to the right as we're going up on the right side of this. And if we go to the left side of our graph of this function, it's pointing to the left. So our domain is going to be all the x values from negative infinity to positive infinity. Now, the range, we're looking at y values. So on the right side of our graph, it's still going up, so that's going to go up to positive infinity. On the left side, it's coming down, it's getting closer and closer to a value and stopping. Now, that value is, right here, negative 4, because it's between negative 3 and negative 5. So we write our interval that y is an element from negative 4 to positive infinity. Part D, we're going to find the average rate of change from the x value of 0 to the x value of 2. So to find these points, we go to 0 on the x-axis and move down till we cross the graph. That's our first point. We go over to 2 and go up to where it intersects the graph. So these are our 2 points. Finding the average rate of change is just like finding our slope. So we're going to go right 2, so that's a positive 2, and we're going to go up 15. So our average rate of change is 15 over 2. And then E, we're looking for the equation of the asymptote. This does have an asymptote because it's an exponential. And our asymptote is here at the bottom.
where it continues to get closer and closer to -4, but doesn't reach it. So the equation is y equals -4. This concludes the video for lesson 4-6, Key Features of a Graph for Secondary 1 Math.